Hi class. So we just have two sections left in the class. Note that sections 10.3 and 10.4 from the textbook are not in this course. But however, to understand section 10.5, there is some information from section 10.4 that we need just to review, and I have that information here below. So we're still focusing on quadratic functions. So if I graph the function in this form, then this form is helpful because it tells me a lot of characteristics about the quadratic function. First of all, the vertex, right? So if I have a quadratic, it looks like a U. Remember that this point, this is called the vertex, right? So we can have a U that opens up, or we could have a U that opens down. So then the vertex would be here. Right, so the vertex is located at HK, right? So whatever this number is and this number is, we just plug those in, and then we have that, right? And then number two is about the axis of symmetry. Correct this. This was wrong in the textbook. They should have had x equals h, right? Instead of x comma h. So that was just a typo from the text. So the axis of symmetry, like if we look down here at these graphs, this dashed line here, that's the axis of symmetry. Oops. Hang on, I didn't mean to move that. Right there. So this dashed line is the axis of symmetry. Right? Same thing here. Right, that's also the axis symmetry. So to find that equation, we just do x equals and then the x value of the vertex, right, which is h. And then, depending on the a value, that's going to tell us if it opens upward or downward, right? So like this graph is when a is bigger than 0. So when that opens upward, then this k value is going to be a minimum value, right, a minimum point. And then when a is less than 0 and a is negative, it's going to force the graph to open downward, right, like this chart. And then k is considered the maximum value, right? So that's the biggest value that can occur, right? So you want to be comfortable with that. So then now looking into this section, we have example 1. So we have f of x equals x squared plus 8x minus 1. And I want to write the equation in that form that we just talked about. And to do this, you're going to have to complete the square, right? So we would have f of x equals x squared plus 8x minus 1. And then I can complete the square, right? So remember, I take b divided by 2 quantity squared. So b in this case is 8. So 8 divided by 2 squared is equal to 16, right? So in other words, in order to complete the square, I want this to be a plus 16, right? But I still have a minus 1, and since I added 16, I have to subtract 16 to keep that balanced, right? Because if I add 16 and subtract 16, I've essentially just added 0, so I didn't change the function, right? But this part that I underlined, that's what's going to produce the perfect square, right? So then what we get is f of x equals, and this factors to be x plus 4 quantity squared, and then minus 1 minus 16 is minus 17, right? So this equation is in that form that we're after, right? So what we want to do is identify the vertex, axis of symmetry, and the minimum value of the function, right? So the vertex is going to be equal to h comma k, right? But something to keep in mind is, remember the equation that we looked at before, the format looks like this, right? So that you want to be careful here because this is h, but h here is actually going to be negative 4, right? Because this would be like minus negative 4, right, to get the plus. And then this value is k, so k is negative 17, right? So the vertex is going to be at negative 4 comma negative 17. And then the next thing that we want to find is the axis of symmetry. So remember, the axis of symmetry is just x equals h, right? In other words, x equals -4. Right? So then lastly, we want to find the minimum value. So the minimum value is going to equal k, which is -17. Right? So not too bad for that one. So let's go to the next page. I have example 2 listed. So we're essentially doing the same thing, but I added a couple other steps. We want to determine the x and y intercepts and also to sketch a graph of the function. So, just like before, the very first thing we want to do is complete the square. But here, what I would do first is to factor out a, since it's not equal to 1. So this would be minus 6x, and then I'm actually going to leave the -5 alone, leave that outside, right? So in other words, what I did is put parentheses around these first two terms and then just factored out a -1, right? And then now what we want to do is complete the square. So I need to take a -6 divided by 2 quantity squared, right? Because that's my b divided by 2 quantity squared. So that's going to be -3 squared, which is 9. Right, so this would give me g of x equals -1 times x squared minus 6x plus 9 minus 5. Right, but I need to balance this part that I added. Right, so I added 9 inside, but when we distribute, that's really a -9, right? Because -1 times 9 is -9. So what I need to do is add 9 out here to balance that out, right? Because I might have added 9 inside the parentheses, but overall, the overall effect is that I subtracted 9, right? Because when I multiply the -1 through, right? So it's important to pay attention to that. So then this would give me g of x equals -1 times, and this factors to be x minus 3 quantity squared, and then -5 plus 9 is plus 4. Right, so then we don't have to have the -1 in front. We could just have a negative sign, right, to make that maybe a little cleaner. And there's the function. Right, so I want to know the vertex. So the vertex is hk, which is 3, 4. Right? Because remember it's x minus h inside the parenthesis. And then we want to know next the axis of symmetry. So remember, that's going to be x equals h, which is 3. And then the minimum value is equal to k, which is 4. Right. So then next we want to find any x and y intercepts. So really quick, I could excuse me, use a different color. I could do b squared minus 4ac really quick. Remember, that's called the discriminant, just to see how many x intercepts I have, right? Because remember, if b squared minus 4ac is bigger than 0, then we're going to have two x intercepts. If b squared minus 4ac is less than 0, we're going to have 0 x intercepts. And then lastly, if b squared minus 4ac is equal to 0, I'm going to have 1 x intercept. Oops. All right, so just remember that from previous section. So our discriminant would be equal to excuse me. So a is -1, b is 6, and c is -5. All right, so if I plug these in, we would get 6 squared minus 4 times -1 times -5, which equals 36 minus 20, which is 16. Right, so this is bigger than 0, so I'm going to have 2 x intercepts, right? And 16 is a perfect square, so remember, specifically, we're going to have 2 rational zeros, right? So we can write those as fractions, right? So I can use the quadratic formula to find the x-intercepts, right? Which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, right? So my b value was 6. So this would be negative 6 plus minus. And then I actually already found the discriminant, right? That's 16. And then divided by 2a, so that'd be 2 times negative 1, right? So this equals negative 6 plus minus 4, all divided by negative 2, which is equal to 3 plus minus 2, right? So in other words, what we have is that x equals, so 3 plus 2 is 5, or x equals 3 minus 2, which is 1, right? So my x-intercepts are going to be the points 5, 0, and 1, 0. Right? So then now moving on to the y-intercepts, we would, remember for the y-intercept, you're essentially going to find f of 0. So if I plug 0 into the function, that would be negative 0 squared plus 6 times 0 minus 5. So then f of 0 becomes, we get negative 5, right? So that point is going to be the point 0, comma, negative 5. Right? And then just another note that we can conclude. So a was it negative 1? Yeah, negative 1. And this is less than 0. So the information that tells me if a is negative, it's going to open downward, right, from that that initial table that we had. So to sketch this graph, right, we just need to plot the points, interesting points. Hang on. 2, 3, 4, 5. Right. So so we have the vertex we found to be at the point 3, 4. So that would be here. And then we found x-intercepts at 5, 0 and 1, 0. And then a y-intercept at 0, negative 5. And it opens downward. So if we just connect the dots, we know this is going to be a U shape. It'll look something like this, right? Where this dashed blue line is the axis of symmetry, which is x equals 3. Right, so that's graphing g of x equals negative x squared plus 6x minus 5. Right? And something else that we could have done is, we could have put in some other x values and found, basically completed an XYT chart. Maybe plugged in, 4, 7, so forth, and got some associated y values and plotted those points as well. It's not really necessary, I don't think, to get a sketch of the graph, but you could if you wanted, right? Make it a little more accurate. Right? All right, so the next concept is mainly just me deriving the vertex formula. That's all that's really in the text for this. So if we look at the very bottom of this page, this is the vertex formula, right? So if I have this equation f of x equals ax squared plus bx plus c, when a is not equal to 0, the vertex is given by these two expressions, right? So I think what I'll do is I'll just have you look at my notes online to view this. I'm not going to ask you to derive this formula, but just know that basically what we're doing is we're starting with the standard form of a quadratic, f of x equals ax squared plus bx plus c, and then I'm completing the square, right? So we complete the square. And then we end up with the form f of x equals a times x plus b over 2a quantity squared plus 4ac minus b squared all over 4a. And the important note to get from this part tells me that h is negative b over 2a, and this whole expression is k. Right? So this part is harder to remember than this, right? It's longer. So basically, that's where we get this format. So it's easy just to remember the x value, and then to find the y, you can just plug the x value into the function, right? So definitely know this part that I put in a green box, right? So I'll just let you look at my notes online about how to do that. But it's not something that I'll expect you to memorize or so forth, right? Just a presentation of where that comes from. Right. So then the next page, we start a new concept. So the concept 3 is determining the vertex and intercepts of a quadratic function. So I know really not a lot of new stuff, but we're going to use this vertex formula. So we have f of x. So just to note that a is 1, b is 4, and c is 6. So the vertex formula hk is equal to negative b over 2a, comma, f of negative b over 2a. Right? So I need to find those values. So negative b divided by 2a is equal to negative 4 over 2 times 1, which is negative 2. Right? So the x-coordinate of the vertex is negative 2. And then to find the y-coordinate, we're just going to plug this into the function. So that would be, negative 2 squared plus 4 times negative 2 plus 6. So this ends up simplifying to be 2. Right? So negative 2 comma 2 is the vertex. Right? So this part is the vertex of the parabola. So next we want to determine any x-intercepts. So again, the first thing I would do is look at the discriminant. So just to see the number, right? So b squared minus 4ac would be equal to 4 squared minus 4 times 1 times 6. Whoops. Which this comes out to be 16 minus 24, which is equal to negative 8, which is less than 0. So this tells me there's no x-intercepts, right? So there's no intercepts, right? Another thing that we can do to kind of think through this about the number of intercepts that's going to happen is, if I just plot negative 2, 2, that's going to be somewhere around here. And then the a value is 1, so that tells me my graph opens up, right? So since it opens upward and my vertex is above the x-axis, there's going to be no x-intercepts, right? So when we have no x-intercepts, the picture is going to look something like this, or the case where we have a vertex of the parabola below the x-axis and opens downward, right? So that's one option that can happen. The second option that can happen is that we have one x-intercept, right? And this is going to occur when the vertex is an x-intercept, right? It's the only x-intercept. So we could have like this scenario, or maybe something like this, right? Opening downward, right? So that's going to happen when we have one x-intercept. And then when we have the vertex being like above the x-axis and opening downward, that's when we're going to have two x-intercepts. Or if I have the vertex being below the x-axis and the graph opening up, then we're going to have two x-intercepts, right? So visually, that's how those things can occur, right? So I can think about it kind of visually by knowing where the vertex is, and then does the graph open upward or downward, or we can look at the discriminant, right? They both will tell us that information. So it's just helpful to know we have no x-intercepts, so I don't have to worry about trying to find those, right? Because that can be a lot of work. And then finding the y-intercept, we just need to find f of 0, which is 0 squared plus 4 times 0 plus 6, which equals 6, right? So that gives me the point 0, 6. And A is 1, like we talked about, so that opens upward. Right, just another fact. We weren't asked to find that, but that would be helpful for sketching the graph. Right, so if I want to sketch this graph really quick, so right, here's x, here's my y-axis. So my vertex is at the point -2, 2. And we have a y-intercept at 0, 6. And then my graph, it looks like a U shape, right? So it's going to look something like this, where this dashed line, x equals -2, is the axis of symmetry. Right? So there's just a rough sketch of the graph. Right, so the next example, example 4, is very similar to the last one. So just to get some more practice with this, so A is -2, B is -12, and C is -19 in this function. Right, so same thing, the vertex HK is equal to -b divided by 2a, comma, and then plugging that into the function. So -b divided by 2a is equal to, that would be positive 12, right? Because -12 would be positive 12, divided by 2 times -2, which this equals 12 divided by -4, which is -3. Oops. So then I need to find f of -3, which equals -2 times -3 quantity squared minus 12 times -3 minus 19, and this simplifies to be -1. Right, so my vertex is the point -3, comma, -1. Right? So then if I just think about this, so this is what I was asked to find for part A, right? So now I want to find any x and y intercepts. So if I just kind of graph this a little bit, just a rough sketch, -3, -1 is going to be somewhere around here, right? That's my vertex. And then A is equal to -2, which is less than 0. So that tells me my graph opens downward. So the graph is going to open downward somewhat, right? So this isn't really a sketch. This is like almost less than a sketch, but just to help me see a relationship between the x-intercepts, right? So what this tells me is that there's no x-intercepts, right? And we could also look at the discriminant. The discriminant for this would actually be -8. So since that's negative, that's going to tell me there's no x-intercepts, right? So you could do that as well. And then in terms of the y-intercepts, we just want to look at f of 0. Well, f of 0 is always going to be equal to c, right? So that's going to be equal to -19. So the x-intercept is 0, comma, -19, the y-intercept, right? So then in terms of getting a rough sketch of the graph, I think for this one, I'll use some graph paper. All right, so I'm just going to come off to the side and use some graph paper. All right, so there's -19, and then see, I need -3. There's x, there's y. Right, so the vertex is at -3, -1 right here. And then we have this point here, which is a y-intercept. And then I can just kind of try to make this U shape. Right, so we get a rough sketch, something like this. Right? So there's part F. Well, actually that would be part C. I guess I made a not a big deal, right? But this is a D, E, F, and that should be A, B, C, but no big deal, right? We'll just leave it as those parts, right? So then now we have two problems left that are application based. So example 5 isn't too bad. Example 6 probably a little harder. We're going to use solving system of equations. So example 5, we just have that an object is launched into the air with initial velocity of 48 feet per second from the top of a building 288 feet high. The height h of t of the object after t seconds is given by this formula. Find the time it takes for the object to reach its maximum height, right? So a is equal to negative 16, which is less than 0. So that tells me my graph is opening downward, right? So this maximum height occurs at the vertex, right? So that's what I want to find, right? So I want to find h comma k. Which instead of using f, I'll use h of negative b comma negative b over 2a, right? Because I'm using the h function. So then, negative b divided by 2a is going to equal negative 48 over 2 times negative 16, which is equal to 1.5, right? So then what we want to find is h of 1.5, right? I noticed in my key I accidentally used f here and here. Not a big deal. I mean, for consistency, I should have used that. But also calling this the h function is kind of confusing with that h for the vertex. So I don't know, if it was me, I probably would have changed this to f of t. But anyway, no big deal, right? So then h of 1.5 comes out to be 324, right? So if you plug 1.5 in for t and for this into this function, you should get 324. So this information is actually going to come in down here, right? So my vertex occurs at 1.5 comma 324. So the actual solution for part A would be the time to reach the max height is t equals 1.5 seconds. And for part B, the max height would occur at 324 feet. All right, so that one's not too bad. So then now we're ready for the next one, example 6. So we're asked to write an equation that goes, equation of the parabola that passes through the points 1, 1, negative 2, 1, and 3, negative 9, right? So I think what I'm going to do is just come off to the side to write this out. So you should have enough room on the piece of paper, but I think that might be a little easier for me. So we want to go through the points 1, 1, negative 2, comma 1, and 3, comma negative 9. Right. So what you want to remember is, the basic form of a quadratic looks like this: y equals ax squared plus bx plus c. Right. So we're going to need to know this. So then what I can do is I can plug in the point 1, comma 1. Whoops. How about I don't think I'm going to use blue since that's the background. Right. If I use 1, comma 1, if I plug that in, what we would end up getting is 1 equals a times 1 squared plus b times 1 plus c, right? So I plugged 1 in for x and 1 for y. This would simplify to be 1 equals a plus b plus c, all right? So I'm going to gather these. Essentially what we're going to get are 3 linear equations with a, b's, and c's in them, and then we're going to solve the system of equations, right? So I'm going to use the addition method to solve the system of equations. So then the next point is the point negative 2, comma 1. So this would give me 1 equals a times negative 2 squared plus b times negative 2 plus c, which gives me 1 equals 4a minus 2b plus c. Right, so 1 equals 4a minus 2b plus c. And then lastly, we need to plug in the point 3 3 comma negative 9. So that gives me negative 9 equals a times 3 squared plus b times 3 plus c. So we get negative 9 equals 9a plus 3b plus c. Right? So then how I like to do this with the addition method is I like to number my equations, and I put a circle around them just so I know what the equations are, right? So then I like to make notes to myself when I'm eliminating the variables. So essentially, I think it'd be really easy to eliminate c twice. So if I take negative 1 times equation 1 and add it to equation 2, we're going to cancel c, right? So negative 1 times equation 1 would be negative 1 equals negative a minus b minus c, right? You just multiply everything times negative 1 on both sides. And then if I write down equation 2, that would give me 1 equals 4a minus 2b plus c. And then I just add these equations together. So on the left-hand side, we get 0 equals 3a minus 3b, and then that's 0, right? And then actually, I can factor out a 3 from the right side, and then divide both sides by 3, which gives me 0 equals a minus b, right? So I like to call this equation 4, right? So then another thing I can do is I can take equation 1, negative 1 times equation 1, and then add it to equation 3, and this will also cancel out the c variable, right? So that would be negative 1 equals negative a minus b minus c, and then add equation 3 to it. So just copy and paste that down. And when I add these, of course the c's cancel like we want, so we get negative 10 equals let's see, that would be 8a plus 2b, and then I can actually factor out a negative 2 out of both sides, or excuse me, just a 2. So then I can divide both sides by 2, which gives me negative 5 equals 4a plus b, right? So just trying to simplify that down as much as possible. So I call this equation 5, right? So then what we do is we make a new system with equation 4 and 5. And then we want to eliminate a variable again, right? But notice if I take equation 4, add it to equation 5, I'm going to cancel out b, right? So in other words, I'm going to get b by itself. So we would have 0 equals a minus b plus negative 5 equals 4a plus b. So the b's cancel. I get 5a on the right side and negative 5 on the left. Divide both sides by 5, and we get a equals negative 1. Right? So then I can find b pretty easy by just substituting it into one of these equations. Right? So if I just take 0 equals a minus b and plug in my a value, I get 0 equals negative 1 minus b. Then I can add b to both sides, and I get b equals negative 1. Right? So we need that. And then I still need a c. So what I can do is take one of these equations. I'll just pick the first one. It's kind of probably the easiest, and plug in a and b to find c, right? So we have 1 equals a plus b plus c. So 1 equals negative 1 minus 1 plus c. So 1 equals negative 2 plus c, and then add 2 to both sides, and I get 3 equals c, right? So now that I know what a, b, and c are, I know what the equation is going to be, right? Because we have y equals ax squared plus bx plus c. What I need to know are the values for a, b, and c, right? And I know those. So my equation would be y equals negative 1x squared minus 1x plus 3. Or in other words, y equals negative x squared minus x plus 3. And I could write that using functional notation if I wanted. like this. Right? So that is the function of the parabola going through those 3 points. Right? So just kind of a interesting connection, using systems of linear equations. Right? All right, so that's all I have for this section. Make sure you let me know if you have any trouble.